Hi, we're coming to you from my front porch here for the algebra review. And first one here is just an equation, just kind of kick some of the rust off here. We're spreading this 2/3 to both of those, so we're going to get 2/3 x plus. And when you do a fraction times this, a couple different ways you can think of it. You can do 2 times 6 is 12, 12 divided by 3 is 4. Or you can reverse it, 6 divided by 3 is 2, 2 times 2 is 4. Don't overcomplicate fractions. They don't have to be super scary things. You can do them for sure. Over here, 2 times x is 2x, 2 times -4 is -8. Whenever we have variables on both sides, we got to get rid of one of them, and usually the one that has the smaller coefficient is what we want to do. So we're going to subtract 2/3 x from both sides. And again, don't overcomplicate fractions. Since this is 2/3, we want this to be written in terms of thirds as well. So 2 is the same as 6/3. 6 divided by 3 would still be 2. And 6/3 minus 2/3 would give us 4/3. Again, I think sometimes when you learn it in middle school, they make it so complicated to try to, I don't know, scare you. I don't know what they're doing, but it doesn't have to be a complicated. It's actually a pretty simple thing right there. All right. Now we're going to add the 8 over. I get 12 equal to 4/3 x. And again, you got a couple options here. Since this is 4 times x divided by 3, we can do the opposite of that. So I could multiply by 3 to cancel that, which gives me 36, and then divide by 4. And we'll end up with x equal to 9. Okay. If we wanted to, we could plug that back in and check it out, make sure it works on both sides, but that's how we do that first one. Over here, similar idea, we're going to multiply by 5, and we'll get 10 minus 5x equals x over 4. Now, I could add this 5x and create a fraction over here if I wanted to. There's nothing wrong with that. I think what I'm going to do is just to show some different varieties, things that we can do. I'm going to get rid of this 4 by multiplying both sides by 4. So that cancels it. I get x equal to 40 minus 20x. Now if I add that 20x over to here, then 1x plus 20x is 21x equal to 40. And then I can divide and I'll get x equal to 40 over 21. Okay. Again, we're trying to just get this simple, quick. We don't want to feel like these are super complicated. Just have some basic techniques for doing them. Over here, I would divide by that 20 first, and we get square root of x equal to 5/20. I can divide both of those by 5, make that a 1/4. Okay. Now I have this square root, and I want to do the opposite of that. So the opposite of square root is to square. So I'm going to square both sides. It's going to cancel that out. And 1/4 squared is 1/4 times 1/4. So if you think about that, 1/4 times 1/4, 1 times 1 on the top is still 1. 4 times 4 on the bottom is 16. So we get that right there. Okay. For this one, I'm going to show you 2 different ways to do it. And again, it doesn't really matter which way you go. It's really kind of up to you. So the quickest way to do it is to raise both sides to what we call the reciprocal power. So since this is 3/2, the reciprocal of that would be 2/3. All right, and the reason that works is because exponent rule says we would multiply these exponents here. So 3/2 times 2/3 is 1, and we end up with x to the first, or just x, equals. And then 27 to the 2/3. We need to be able to do that without a calculator. So I'm always going to do the root first, the third root of 27. What times itself 3 times would give me 27, and that would be 3. And then I'm going to do 3 to the second power. 3 times 3 is 9. So I get x equal 9. Okay. Another way to think about it, and that's probably the quickest way to do it, but if you got a little stuck and you needed some help, maybe rewrite this. So this would be x to the third power. The 3 is the power. The 2 is the square root. All right, and then you could get rid of your square first. All right, so you'd have x to the third equal to whatever 27 squared is. All right, and then we'd have to take the third root of that. Okay, and I think this is like 729. In fact, I'm going to say it's 729. Then we take the square root of that. or take the third root of that, and that would be 9. Okay. Now, obviously, that's a little easier maybe at first to see what that 3/2 looks like, but then it became a little harder to actually navigate. So I would encourage us to do this. This is probably the better way to go in terms of solving it. X to the negative 1/2, we have to understand that a negative exponent means we're going 1 over whatever that is, and the 1/2 power means square root. So another way of writing x to the negative 1/2 would be 1 over square root of x. All right, we want to get that into our head quickly so that every time we see a negative, that means it's on the bottom, and that a half or whatever, it just is that radical. Now, from here, there's different ways you can go. I would maybe multiply by the square root of x on both sides. Get it off the bottom. We've got 1 equals 4 times square root of x, and then maybe divide by 4. So I get 1/4 equals square root of x, and then we can square both sides. This is maybe a little more work than you need to, but maybe it makes the most sense in terms of where we were heading. Again, just like over here, though, you could have, if you wanted to, did a reciprocal power on that. Oh, you had a blowout on the pencil. All right. Luckily, I've got a backup here. So if we got x to the negative 1/2, what I can do is the reciprocal of that. The reciprocal of that's -2. And that's going to cancel there, and now I've got x equal 4 to the negative 2. The negative means 1 over, and 4 squared is 16. So again, that's probably the quickest way to go, but both ways gets it done. All right. Then we had some inequalities here, and we wanted to express it in interval notation. So we saw these very similarly to like an irregular equation. We're going to subtract 6, -3 less than or equal to -2x. The only thing to keep in mind with inequalities is if we divide or multiply by a negative, then we have to flip this sign. So because I am dividing by -2, I get 3/2 not less than, but now greater than or equal to x. That's the only rule that we got to kind of keep in mind here. Now what this is saying is that x can be anything that's less than 3/2, or 3/2 has to be greater than x, right? So if you think about a number line, we'll do it number line first, okay? Here's your 3/2. 3/2 has to be bigger than it, so it can't be something over here. It has to be something over in there. So it'd be in this realm over here, right? And it could equal 3/2, so we'd have that filled in circle there, right? That's probably what you remember from algebra and algebra 2 and stuff. What we're going to do now is introduce just another way of expressing it. And what we're saying here is that all the numbers that are less than, so this is heading off to what we call negative infinity. So anything from negative infinity all the way to this 3/2, all of these numbers are included. So this is not an ordered pair like you might graph on a XY axis or something. We're saying that all the numbers from here to here are part of our solution. Now we can include 3/2, so if we can equal it, then we put that bracket on it. And since you can't actually equal infinity, it's something that keeps growing, you never can capture it. We use a parenthesis to indicate that we're not equal to that. So if this had been an open circle, we would have had a parenthesis on that as well. Okay, so we'll see that here on this one. We've got 4x plus 1 in between two numbers, so when we subtract this 1, we're going to be fair and subtract it from everything. So everybody gets a subtracting 1. All right, and then we're going to divide everybody by 4. And what that ends up telling us is that x can be anything in between -2 and +2, but it can't equal either of those. Again, from a number line perspective, it would look like this. We're between -2 and 2. So everything here, but not anything past 2, not anything before -2. So in terms of an interval notation, this is pretty simple. We're just saying anything from -2 to 2, any of these numbers between there can be included. We can't equal -2, so we put a parenthesis around it. We can't equal 2, so we put a parenthesis around there. So this would be our answer in that interval notation. Then the last one we're going to look at here on page 1 is when we have an absolute value less than 7. So we want to think about, well, what numbers have an absolute value that's less than 7? 6, 5, 4, 3, all the way down. So anything from 7 all the way down until you get to -7. So it's kind of like this interval notation here, right? We're saying anything between -7 and 7 has an absolute value less than 7. So we're going to say then that this x minus 4 could be any of those numbers that are between here and here, because the absolute value of this would then be between 7. And once we have that setup understood, then the rest of the problem is real simple. But it's going to be that setup that could cause you a little bit of grief. So you want to try to understand. When it's less than, we're going to set it up like this. Greater than is a little different story. All right, interval notation says that we're anything between -3 and 11, but not including those. So that would be our answer there.